Hello students, in our previous class we have studied about operations on rational numbers. So in continuation of that, now we are going to learn some of the identities which hold true for any given two real numbers. So given for positive real numbers a and b, the following identities hold. Identity 1, root AB equal to root A root B. For example, root 2 into 3 equal to root 2 multiplied by root 3. Next, in the second identity, under root A by B equal to root A by root B. For example, under root 2 by 3 equal to root 2 by root 3. Next, moving on to the next identity number 3. Here, root A plus root B whole into root A minus root B equal to A minus B. Here we are using the identity A plus B whole into A minus B equal to A square minus B square. So accordingly, if we multiply this number, then we will get root A square minus root B square, which is equal to A minus B. Here one must remember that root A into root A equal to A. That is, for any two irrational number, root 2 into, for example, root 2 into root 2, we get 2, or root 3 into root 3 equal to 3. So root A plus root B whole into root A minus root B equal to A minus B. Same here also in Roman number 4, we are using the same identity A plus B whole into A minus B equal to A square minus B square. So A plus root B whole into A minus root B, we get A square minus B. Let us expand this and see how this A square minus B is coming. So A plus root B A minus root B, which is equal to A square minus root B square equal to A square minus root B into root B is B. So A square minus B. Next, moving on to the last identity, there is root A plus root B whole square. Here we are using the identity A plus B whole square, which gives A square plus twice AB plus B square. So root A plus root B whole square, root A plus root B whole square equal to, it will be root A square plus twice root A root B plus root B square. Root A square is A, then because root A into root A equal to A, plus twice it will be root AB. Here we are using the first identity, then root B square equal to B. So root A plus root B whole square equal to A plus twice root AB plus B. So here are some of the identities which you are to learn for any given real numbers A and B. Next, our topic is rationalizing factor. So if the product of two irrational numbers is a rational number, then each is called a rationalizing factor of the other. So if we multiply any two irrational number and the product is a rational number, then we will call the two numbers as the rationalizing factor of each other. Let us take up an example and try to understand what is a rationalizing factor. So for example, if 2 plus root 3, which is an irrational number, is multiplied by another irrational number 2 minus root 3, we will get an irrational number. How? Here we are going to use the identity a plus b whole into a minus b, which is a square minus b square. This is 2 square 4 minus root 3 square is 3 equal to 1. 1 is a rational number. So here two irrational number 2 plus root 3 and 2 minus root 3 are multiplied and we get a rational number. So these two are the rationalizing factor of each other. That is, 2 plus root 3 is the rationalizing factor of 2 minus root 3, and in the same way 2 minus root 3 is the rationalizing factor of 2 plus root 3. So this is an idea about the rationalizing factor. Next, our topic is rationalizing the denominator. So when the denominator of an expression contains a term with a square root, the process of converting it into an equivalent expression whose denominator is a rational number is called rationalizing the denominator. So in other words, converting the denominator into a rational number is called rationalizing the denominator. For example, the number 1 by 2 plus root 3 is an irrational number. The denominator 2 plus root 3 is an irrational number, and we are to convert this denominator into a rational number. So we have to multiply this number both in the numerator and denominator by the rationalizing factor of 2 plus root 3, which is 2 minus root 3. So multiplying both numerator and denominator by 2 minus root 3, we will get 2 minus root 3 by 2 square minus root 3 square equal to, which is 2 minus root 3 by 4 minus 3 equal to 2 minus root 3 by 1. So here the denominator is converted into a rational number. So converting the denominator into a rational number is called rationalizing the denominator. Next, our topic is laws of exponents for real numbers. Let a is greater than 0 be a real numbers and p and q be rational numbers, then the following laws of exponents is true for real numbers. Roman number 1, a to the power b into a to the power q equal to a to the power p plus q. Roman number 2, a to the power p to the power q equal to a to the power pq. Roman number 3, a to the power p by a to the power q equal to a to the power p minus q. Roman number 4, a to the power p multiplied by b to the power p equal to a to the power ab to the power p. We'll try to understand these laws of exponent as we try to solve some of the questions from exercise 1.6. Now let us try to solve some of the questions from exercise 1.5. So exercise 1.5, question number 1, classify the following numbers as rational or irrational numbers. So here you are to identify the given number as either rational or irrational number. So command number 1, 2 minus root 5. Here 2 is a rational number and root 5 is a irrational number. So this will be an irrational number. Irrational number. Subtracting an irrational number from a rational number, we will get an irrational number. Moving on to next question, that is Roman number 2. 3 plus root 23 minus root 23. This will give us 3 plus root 23, opening the bracket, minus root 23 equal to 3. 3 is a rational number, so the whole number will be a rational number. Next, Roman number 3, 2 root 7 by 7 root 7. This is equal to 2 by 7, as root 7 and root 7 at the numerator and denominator will cancel it out. So 2 by 7 is a rational number. So the given number will be a rational number. Next, Roman number 4, 1 by 2. This will be an irrational number. Next, Roman number 5, 2 pi will be an irrational number, because here the number pi is an irrational number. So in question number 1, Roman number 1, 4 and 5 will be an irrational number, and Roman number 2 and 3 will be your rational number. Next, exercise 1.5, question number 2, simplify each of the following expression. Roman number 1, 3 plus root 3 whole into 2 plus root 2. So, solution, 3 plus root 3 multiplied by whole into 2 plus root 2 equal to here we will multiply 3 with 2 and 3 with root 2. So 3 into 2 plus 3 into root 2. Then we will multiply root 3 with 2 and root 3 with root 2. So next we will get plus 2 into root 3 and root 3 into root 2. So 3 into 2 we will get 6, plus 3 into root 2 we will get 3 root 2, plus 2 into root 3 to root 3, plus root 3 into root 2 we will get root 6. Therefore, the simplification of the given expression will be 6 plus 3 root 3 plus 2 root 3 plus root 6. Next, exercise 1.5, question number 2, Roman number 2. In Roman number 2, 3 plus root 3 whole into 3 minus root 3. Here we are going to use one of the identity for real numbers, that is a plus root b whole into a minus root b equal to a square minus b. So using this identity, 3 plus root 3 whole into 3 minus root 3 equal to 3 square minus root 3 square equal to 9. 3 square is 9 minus root 3 square is 3. That is root 3 into root 3 equal to 3, which is equal to 6. So after simplification, the expression 3 plus root 3 whole into 3 minus root 3, we will get 6. Next, exercise 1.5, question number 2, Roman number 3, root 5 plus root 2 whole square. Here we are going to use one of the identity for real numbers, that is root a plus root b whole square equal to a plus twice root ab plus b. So in other words, we are going to use the identity a plus b whole square. So root 5 plus root 2 whole square equal to root 5 square plus twice root 5 root 2 plus root 2 whole square equal to 5 plus 2 root 5 into root 2 equal to root 5 into 2 plus root 2 square equal to 2 plus equal to, here we will add 5 with 2 and we will get 7. 5 plus 2, 7 plus 2 root 5 into 2 equal to root 10. So after simplification, we will get 7 plus 2 root 10 as our required answer. Next, exercise 1.5, question number 2, Roman number 4, root 5 minus root 2 whole into root 5 plus root 2. So solution, root 5 minus root 2 whole into root 5 plus root 2. This will become root 5 square minus root 2 square. That is a plus b whole into a minus b equal to a square minus b square. Now root 5 square is 5. That is root 5 into root 5 equal to 5 minus root 2 square is 2. Now 5 minus 2 is 3. So for Roman number 4, after simplification, we will get 3 as our required answer. Next, exercise 1.5, question number 5, rationalize the denominators of the following. Roman number 1 by root 7. So we are to rationalize the denominator of the number 1 by root 7. So solution, to rationalize this number, we have to multiply both the numerator and denominator of this number by the rationalizing factor of root 7. That is, we have to multiply by root 7. 1 root 7 into root 7 equal to root 7 by root 7 into root 7 is 7. So the denominator becomes a rational number. So the final answer will be root 7 by 7. Next, Roman number 2. 1 by root 7 minus root 6. So here also, to rationalize the denominator, we have to multiply both the numerator and denominator by root 7 plus root 6, which is the rationalizing factor of root 7 minus root 6. So therefore 1 by root 7 minus root 6 equal to 1 into root 7 plus root 6. Root 7 minus root 6 whole into root 7 plus root 6. This is equal to root 7 plus root 6 by, this will become a minus b, that is 7 minus 6, using one of the identity, equal to root 7 plus root 6. The denominator will become 1. 7 minus 6 is 1. So our required answer will be root 7 plus root 6. Next, exercise 1.5, question number 5, Roman number 3, 1 by root 5 plus root 2. So, solution 1 by root 5 plus root 2 equal to, here also we are to multiply both the numerators and denominators by the rationalizing factor of root 5 plus root 2. Therefore, it will be 1 into root 5 minus root 2 equal to root 5 plus root 2 multiplied by root 5 minus root 2 equal to, numerator will become root 5 minus root 2, then denominator will be 5 root 5 square minus root 2 square, root 5 square minus root 2 square equal to root 5 minus root 2 by, this will become 5 root 5 square is 5 minus root 2 square is 2 equal to root 5 minus root 2 by 5 minus 2 is 3. So after rationalizing the denominator, we will get root 5 minus root 2 by 3 as our required solution to the question Roman number 3. Next, exercise 1.5, question number 5, Roman number 4, 1 by root 7 minus root 2. So solution 1 by root 7 minus 2 equal to 1 into root 7 plus 2, which is the rationalizing factor of the given denominator. So root 7 minus 2 multiplied by root 7 plus 2 equal to root 7 plus 2 by, this will become root 7 square minus 2 square equal to root 7 plus 2 by root 7 square is 7 minus 2 square is 4. So root 7 plus 2 by 3. So after rationalizing the given number, we will get root 7 plus 2 by 3 as our required answer. Next, exercise 1.6, question number 1, find the value of Roman number 1, 64 to the power 1 by 2, Roman number 2, 32 to the power 1 by 5, Roman number 3, 125 to the power 1 by 3. Now, let us try to solve each of these questions. So first, moving on to question number Roman number 1, 64 to the power 1 by 2. So solution 64 to the power 1 by 2 equal to, first let us prime factorize the number 64. 64 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So therefore 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. There is 2 to the power 6. So 64 is equal to 2 to the power 6. So therefore 64 can be written as 2 to the power 6 to the power 1 by 2. Now next we will use one of the laws of exponent, that is a to the power p to the power q is equal to a to the power p q. So using this identity, we will get 2 to the power 6 into 1 by 2. So this will become 2 to the power 3. to the power 3 is 2 into 2 into 2, which is 8. So our required answer will be 8. Next, let us try to solve Roman number 2, that is 32 to the power 1 by 5. So Roman number 2, 32 to the power 1 by 5. Solution. Same as first, we will prime factorize the number 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So 32 can be written as 2 into 2 into 2 into 1, 2, 3, 4, 5. 2, 5 times. So 32 is equal to 2 to the power 5. So 2 to the power 5 to the power 1 by 5. So this will become 2 to the power 5 into 1 by 5. This will cancel out. This will become to the power 1, which is 2. So the required answer to the expression 32 to the power 1 by 5 will be 2. Next, Roman number 3. Roman number 3, 125 to the power 1 by 3. 125 to the power 1 by 3. Solution. Prime factorize. Let us prime factorize this 125. 5 times 25. 5 times 5. So 125 can be written as 5 to the power 3 to the power 1 by 3 equal to 5. 3 into 1 by 3 equal to 5 to the power 1, which is equal to 5. So the required answer is 5. Next, exercise 1.6, question number 2. Find the value of Roman number 1, 9 to the power 3 by 2. Roman number 2, 32 to the power 2 by 5. Roman number 3, 16 to the power 3 by 4. And Roman number 4, 125 to the power minus 1 by 3. So let us first solve Roman number 1. Roman number 1, 9 to the power 3 by 2. Solution. 9 to the power 3 by 2 equal to 9 can be written as 3 to the power 2. 3 square is 9, so 9, instead of 9 we write 3 to the power 2, then to the power 3 by 2, which is equal to 3 to the power 2 into 3 by 2. This 2 and 2 will cancel out, then we will get 3 to the power 3. 3 to the power 3 is equal to 3 square is 9, 9 into 3, 27. This is equal to 3 cube is 27. So the required answer is 27. Again, moving on to the question Roman number 2, 32 to the power 2 by 5. Solution. 32 to the power 2 by 5 equal to 32. After prime factorization, we can write that 2 as 2 to the power 5 to the power 2 by 5 equal to 2, 5 into 2 to the 2 by 5. 5 and 5 will cancel, equal to 2 to the power 2, which is 4. 2 square is 4. So for Roman number 2, the required answer is 4. Next, let us try to solve the remaining Roman number 3 and 4. So Roman number 3, 16 to the power 3 by 4. Solution 16 to the power 3 by 4 equal to, instead of 16 we can write to the cube power 4. That is 2 to the power 4 is equal to 16. This will become 3 by 4, which is equal to 2 to the power 4 into 3 by 4. 4 and 4. Then this will become 2 cube equal to 2 cube is equal to 8. So the required answer is 8. Next, Roman number 4. Roman number 4. 125 to the power minus 1 by 3. Solution 125 to the power minus 1 by 3 equal to 125 of the prime factorization. We can write 125 as 5 to the power 3. So 5 to the power 3 to the power minus 1 by 3 equal to 5 to the power 3 into minus 1 by 3. 3 and 3 will cancel each other equal to, this will become 5 to the power minus 1. Here we have to remember one of the laws of exponents, that is 1 by a to the power n equal to a to the power minus n. So 5 to the power minus 1 can be written as 1 to the power 1 by 5. This will become 1 by 5 according to this law of exponent. So the required answer to Roman number 4 is 1 by 5. Next exercise 1.6, question number 3, simplify Roman number 1 to the power 2 by 3 multiplied by to the power 1 by 5. Roman number 2, 1 to the power 1 by 3 to the power 3 whole to the power 7. Then Roman number 3, 11 to the power 1 by 2 by 11 to the power 1 by 4. So let us first solve Roman number 1, that is to the power 2 by 3 multiplied by to the power 1 by 5 solution. So here we are going to use one of the laws of exponent, that is a to the power p multiplied by a to the power q equal to a to the power p plus q. So applying this law, to the power 2 by 3 to the power 1 by 5 equal to the power 2 by 3 plus 1 by 5. Adding these two fractions, we will get to the power 2 by, taking the LCM, that is 5, LCM of 5 and 3, 15. This numerator will become 10 plus 3 equal to the power 13 by 15. So after simplification, we will get to the power 13 by 15 as our required solution to the question number Roman number 1. Next, Roman number 2. Roman number 2. One by solution equal to, here the number inside the bracket can be written as 3 to the power 1 by 3 to the power minus 3 to the power 7. This is equal to 3 to the power minus 3 into 7 equal to 3 to the power minus 21. So the required answer to the Roman number 2 is 3 to the power minus 21. Next, Roman number 3. Roman number 3, 11 to the power 1 by 2 by 11 to the power 1 by 4. Here also we are going to use the laws of exponents. There is a to the power p by a to the power q equal to a to the power p minus q. So 11 to the power 1 by 2 by 11 to the power 1 by 4, it will become 11 to the power 1 by 2 minus 1 by 4. So subtracting these two fractions, we will get the required answer. So therefore, equal to 11 to the power, taking LCM between 2 and 4, LCM will be 4. The numerator will become 2 minus here 1. So 11 to the power 2 minus 1 is 1. 11 to the power 1 by 4. So the required answer is 11 to the power 1 by 4. Exercise 1.6, question number 3, Roman number 4. Roman number 4, 7 to the power 1 by 2 multiplied by 8 to the power 1 by 2. Here 1 by 2 is same, so we are going to use the laws of exponent. There is a to the power p multiplied by b to the power p equal to ab to the power p. So solution, 7 whole number 1 by 2 multiplied by 8 whole number 1 by 2 equal to, using this law we will get 7 multiplied by